Hi everyone, here we are with Facebook Live. Gonna try to keep this really centered. Now let me put you guys on pause for a second so I can turn this down just a little bit. Okay, there we go. Hopefully you guys can see that. Okie doke. All right. Hi everyone. So, I've been pretty busy. So I actually wanted to start off today, as we talked yesterday a little bit about Flower of Life. And I said I wanted to kind of do a class on the Flower of Life. So I've already taken the time and effort to make a Flower of Life here. And I'm using a smaller compass today because I'm going to do some smaller circles. And smaller circles are actually much harder than larger circles for some reason. So we started off with the regular Flower of Life, but this has got 24 circles in it around the outside. The next is 18, then the next is 12, then the next is 6, and the next is 1. So there are 61 total circles here. But what I'm also trying to illustrate is the nature of how waves propagate and how our number system works, and the role of 24 and 42 as well, which you'll see in just a moment here. So what I did is I started off with a smaller circle, which is going to be approximately exactly half the size in diameter as this central circle right here. And I just have them wave propagate, so they use doubling math. So it just goes at each half point, you just keep going out from center. And so I'm going to continue this process right here, and you'll understand what I'm doing here in a moment. Now, one of the things that's really important here is to press down your compass pretty deep when you're doing smaller circles at the pinpoint, so that you will not have it come out. And that's one of the things that I've made thousands of mistakes on, especially when working with very small circles. See, this one here is not coming out perfect. But close. Okay. So, fractals. Someone asked me recently about fractals and how fractals work. Well, fractals follow Flower of Life pattern. And I could keep doing this, ad infinitum, and go smaller and smaller and smaller. That's the thing with the circle. A circle can be a 0. That means it could be nothing. Or it could be a boundary condition, which then everything can be created from nothing. And the first thing you do is you divide the circle, and then you've got 2. So you've kind of created from nothingness, from the number 0, you've created an infinite number of possibilities that you can do within that circle, because you can keep having a circle infinitely. And every time you have a circle, it's always going to add up to a digital root of 9 in modular arithmetic. So I'm going to do the same thing that I just did here. I'm going to do it now going north-south. Pressing down really hard. I'm trying to do these circles very bold so you can see them. And we're not not listening to classical music today because I don't only listen to classical music. So I had a great time last night finishing up the artwork that we did yesterday, and turned out pretty good. See, that's exactly what I'm trying to avoid. It pops out of the little hole. You got to put it back in. Okay. Now there's a method to this madness. Because every one of these intersections of the flower of life, these wave overlaps, create virtually all of our perceived reality around us. I'll explain how in a moment. Oof. See what I mean about small circles being harder? Okay. Okay, so we're getting close now. The hard part is almost over. And this radio station today is Pandora, and it is Pandora Adele. Okay, so now let's count these up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Let's count this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. Now if we were going to take this all the way out to the edge of the larger circle, I'd go like this. Somehow I got a little off here. That's okay. Okay. So then that's going to give us 2 extra. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So the same both directions. Okay, 19. Interesting prime number with perfect rotational symmetry. So this flower of life can make virtually everything, right? And the way that we would draw off of this is going to be just like this. Let's see, I'll get a little darker lead. One of the things people mess up all the time on this is that you can go with each fractal. So if I wanted to, I could go with this small one right here. And I could draw across the line here. And then I could do my same Merkaba, exact same thing. Another way you could look at this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9. 9 and 0 act the same in digital root math. Now I've done these before where I've had so many different fractals inside here, and it takes a ton of concentration to do it and have it turn out right. Too far on that one. Okay, so there's one fractal we could do. Another one is, of course, you can do this one right here. So you're going to match up this line right to this line. And then within these, you can of course do the same kind of nesting that I showed you yesterday. Now, another thing that's cool about this framing is it actually shows you a lot of those intersections that we were looking for in Metatron's cube as a natural progression of the circle overlaps. And why is that? Why are the circle overlaps so important, right? What is it about those circle overlaps that kind of creates that scenario for us? Well, what it is that it allows us to take from center and every one of the line overlaps. So let's say I wanted to pick that overlap right there. If I take a line across this and take it all the way out, so now I'm intersecting this intersection and this intersection, and also this intersection here, and this will come out to be a mathematical constant. And I can use one of these things to measure the number of degrees that it is also. So I'm going to take this at center. And look, the first thing that it's basically showing me is this is the 30-degree mark. Right? And then if I were to do another one, this is kind of amazing how perfect this is. And how is it that people can think that 360 degrees is arbitrary? I just don't know. Right, so I'll just keep going around this and let's see how many different important constants we can find here. Now, the nice thing about these smaller circles is when you have smaller fractals inside it, you can find the sub-constants as well that become fundamental. There's actually another one right here, too. Because I could even take this and say, this one right here is a crossover here, but it's also a crossover here, where those two circles are overlapping. And I could even go to the next one up here, and then I could assume that this is going to be a fractal or another math constant here too. And all of these will be fundamentally like angles of incidence on a clock as well. You could do it in 360 base math, or you could do it in sexagesimal math, which is 60 minutes, 60 seconds. In fact, our compass system is so genius. The compass probably, and you'll see this in a moment, is probably the very best system we have for measuring not only space, which is how we use compasses today, but since space and time are the same thing, space-time. So each one of these become important angles. So let's just have a look at these and see where these come out. Okay, so this was 30 degrees, because this is at 90, but we'd have to just think of it as 0. And this is 30 degrees right here, right? Now this is giving us 9 degrees. So this is giving me, 19 degrees. And this one is giving me 101 degrees. So it's going to be 11 degrees. And this one right here is going to be 14 degrees, which is the same 14 for pi, the 3.14 to the 1/4 in pi. And then here we're at 100 and, looks like 131 degrees. Sorry, so that means I would subtract it. So it's going to put us at, so 10, 20, 30, 40, so 41 degrees. And then I've got 150 degrees here, so that's going to be from 90, that's 30, so this is 60 degrees. And then this one is going to be at 164, so that's going to be 16 degrees off from 90, so 74 degrees. And we can go around, and each one of these will be fundamental positions of time measurement or relationships that we'll come back to in just a moment. But the most important of the ones that you see on this right here are the same ones that the flower of life just makes very naturally, 30 and 60 degrees. So then 90 degrees, of course, being right over here, is going to be another critically important one. 30, 60, 90, 3, 6, 9 in digital root. 3, 6, 9. And digital root you just accomplish by adding the number within itself. So very simple, right? Ha, okay. Now let's go to something a little bit more complex. Okay. knocked my makeshift camera system over here. Before we get into that, we'll show you this. This is what we made yesterday. So great job, everybody. This was really not easy, I have to admit. It was very complex. But you'll notice also one of the things that was kind of fun to do was to interweave all of these different pieces inside each other, right? So that this is almost like showing how well integrated these geometries are in this one that we just put on here yesterday that was kind of new because it had at least Metatron's cube that we know of. Hexagon, 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 but in hyperdimension. And then this large one, which I thought was perfect for displaying all the complexity that we built on the inside. And so you'll see that I used a lot of different coloration and everything to try to add to the extra dimensionality of this and intertwining it, kind of like an Escher knot, if you've ever seen those, where Escher's art looks like you could look at it from several different angles and it could take your mind to different directions. So that's why I did that the way that I did, but good job, everyone. And thanks for everyone who sent me the similar pictures. Now, you're like, what the heck is this? Holy cow. So this was a work that I did in October of last year. And basically it's titled The Directional Compass of Measurement of Time. And what I did is I basically created this whole circle thing here, which is 360 degrees, but I used it just as you would a compass, right? And based on the number of minutes and seconds of a compass. So a compass actually has 1,296,000 seconds inside its 360 degrees. So the way we look at compass measurement is we say, okay, it's 33 degrees, 33 minutes, and 33 seconds, for example. And so you could make a calculation and make a transference of that data into a decimal. So for example, right, if I take the slope angle of the Great Pyramid slope angle is 51.8436 degrees. But if I were going to make that a conversion into a compass measurement, it would actually come out to be 5150. So 51 degrees, 50 minutes, and 36 seconds. So 51 degrees, 50 minutes, and the way you can make a translation over from minutes into decimal is to just take the 50 minutes and divide it by 60 minutes total, and that will give you 0.83 repeating. Then you take the other 36, you divide that by 60, and that will give you a total conversion from 5150 and 36. So 51 degrees, 50 minutes, and 36 seconds converts directly into 51.8436 degrees. Now, why is any of that even important? Well, let's say, hopefully I can use this, it's okay. So let's say that I have 51 degrees, 50 minutes, 36 seconds, okay? That converts to 51.8436. Now, there's also websites that will do this for you, this conversion. But this conversion becomes really important. Why? Well, if I were going to take and divide phi divided by pi, it equals 0.515036. So there wasn't a connection made, and I found this connection, that it was actually this mathematical equation which defined the slope angle of the Great Pyramid. It's just this is the compass measurement that was used instead of using the decimal measurement. Now, if we just make a conversion, these two are equivalent. So you could say it's almost like it has its own little language, and the Egyptians must have known this. Well, they did. I mean, they had 360 days in their calendar for a reason. It represented 1 day for every degree. And then they had 5 catch-up days, which would be at the end of the year, where it would represent sort of a resurrection, a death and resurrection every new year. And that's why even the pagan date for celebrating that death and resurrection was on Christmas. So it goes way, way back. So 5150 minutes and 36 seconds is equivalent to phi divided by pi. And that is equal, just by moving the decimal position, to the minute, second, and compass measurement that comes out to be the exact slope angle of the Great Pyramid. Now, we discovered that that was also embedded inside the Vitruvian Man. Alan and I had done work on that. We made a video on that if you haven't seen it yet. So I started thinking, well, there must be something more to this whole notion of kind of minutes and seconds in, why this is important. And so I started diving a little bit deeper to understand if there was something I could find more related to time and its potential for true measurement, a different way. I was actually looking for an equation for time. Well, I know that time and gravity are related for sure. There's definitely something called, time dilation that occurs when you've got greater gravity and therefore greater mass in the vicinity. So what I did find was that there was a relationship between gravity divided by the number of seconds in 1 day, which is 86,400, equals the square root of pi minus 1. Now, what a beautiful, simple equation that is, right? That's kind of amazing. Well, this 86,400 seconds thing also was a trigger for me because the diameter of the sun is 864,000 miles. And it just so happens that if you have a diameter of 86,400 or 864,000, doesn't matter by adding zeros to it, that its radius then is 432, which is an important number because 432 squared is light speed. I could also put 1 on the front of this, and this is one of the measured measurements for the speed of the wave of light. and then also, I had noticed that the circumference of a circle with 86,400 as its diameter would just be pi times this number, and it comes out to the Euler number. So if you look up on Google today, the circumference of the sun in miles, it will give you the Euler number. It's 2.718 million miles. And there it was, right in plain sight. The Euler number is the mile measurement of the circumference of the sun. How in the heck did we miss this, right? Well, there you go. And Euler and pi work together to create the separation of light and darkness. And so I started running to see what would happen if I made a compass of time instead, which is what I did here. And I posted on this, but I didn't figure a lot of people would fully understand it. So I thought I'd go ahead and explain it to you guys here today as kind of a little special thing. I have not explained this to many people at all. But basically, if I were to look at the number of minutes and seconds that would be in each of these segments, and remember 30 was an important one, 60 is also an important one, 90, of course, and we saw those as emerging from the flower of life and those wave overlaps. Then you'll find that at the measurement for the slope angle of the Great Pyramid, 51.84 degrees, comes out to be 432 squared, just by coincidence. And 432 squared equals 186,624. It's the closest squaring to light speed that you can have, and it's slightly more than the actual measured speed for light in a vacuum, which comes out to be 186,282 miles per second. And so the difference between this, though, turns out to be basically 342 miles. So it's another permutation of the number 432, 342, 432. So that's really interesting. And I also started putting musical notes on the outside of this because I noticed there was a rotational symmetry related to musicality of time, and that time itself had relationships to music. And each of these numbers that were on here were actually musical notes in hertz frequencies, which are measured in beats per second. So 108 hertz, for example, is the note A. 162 hertz is the note E. 216 hertz is the note A again, all in 432 hertz tuning. 259.2 or 2592 hertz comes out to, again, a C, it basically comes out to an E that relates to this 162, which is phi doubled. And also, if you take 2.592 and you take the square root of 2.592, it comes out to 1.61, which is the golden number, phi. It's what those calipers were I showed you. Now, interestingly, if we kind of go around this chart, we'll see here that 432 shows up right at 120 degrees. So it's the first base angle of the male triangle that shows up as we build the Merkaba. And this system has been around for a long time, the compass measurement system. So each of these become fundamental positions. Another fundamental position here is I get to 5184, so 518,400. That's again the slope angle of the Great Pyramid, just with another couple of zeros on the end of it. And that 5184 comes out to exactly 144 degrees, which turns out to be a D note in tuning, right? And a tuning standard of 432. So each one of these are kind of going back and forth between different kinds of musical notes. Now, what I found in all of this was not only this equation of gravity divided by the number of seconds in one day equals the square root of pi minus 1, but you can also do it the other way around, which is the number of seconds in a day times the square root of pi minus 1 equals gravity. It gives us a very, very, very close approximation. And by the way, gravity as a measurement, big G constant as it's known, is known to be not incredibly accurate for several digits. So then I took 1440 divided by gravity, it gives me 216. So there's clearly some relationship, like a toggle, going back and forth, and then the number 24 divided by gravity gives me 3.6. So creating the circle, or completing the circle. Now, when we look at this from a year's perspective, the number of cycles, right, that we have in a day. So, I mean, a lot of people ask me all the time, like, well, why do we have 365 days in our calendar? Well, the reason why we have 365 days in our calendar is because we're only looking at the solar calendar. We sort of ignored the moon. Go figure, right? I don't know why we did that, why we chose that. But many cultures around the world, the Western cultures have ignored the moon, but many still follow the lunar calendar. And what's interesting about that is that the number of days in the lunar calendar year actually turns out to be 354.8 days in the lunar calendar year. So 354.8. So I'll see if I can basically draw this. So lunar equals 354.8 days. And you can look this up also on Google or whatever. And the solar calendar equals 365.24 days, right? This year is a unique year because we have a leap year. And leap year then says we have 366.24 days. But so if you take these two numbers and you average them, so recognizing that it's a wave, right? And if you wanted to find the sun where it's here and the moon where it's here, it would come out to be, because you have to do the average, 360 days. But only when you recognize the lunar calendar, which represents the feminine. The solar represents the masculine. So I find that fascinating that we have an imbalanced circle, right, until we balance with the feminine in the lunar calendar. I find that really, really interesting. And geez, is this why the Egyptians and the Sumerians chose 360 days for their calendar? Now, I executive produced a film called Sonic Geometry 2, and I did it with the creator of Sonic Geometry 1, which is film on geometry and music and everything. If you have not seen it, I highly recommend for you to see it. Both of them, the part 1 and part 2 turned out really, really well. Eric Rankin is outstanding, and Lana, his friend, basically helped to create and direct the whole thing with him. But it goes into a lot of this kind of 9-based math and its implications on music as well as geometry. And it basically shows as well that if I took the degrees, as I mentioned in one of the earlier classes, if I took the degrees of each of the Platonic solids, starting with the tetrahedron, right? So I just take a simple tetrahedron, it's like this, it equals 720. If I count that as hertz, then the next one up is going to be an octahedron, right? Which we've basically learned how to draw here, right? Kind of goes like this. So the octahedron is 1440 hertz. And so this would equal an F sharp in 432 tuning. This equals the octave higher F sharp. Then the next is a cube, which equals 2160 hertz, which 2160 is a C sharp. And then if we go up the next one, so you've got tetrahedron, octahedron, cube, then the next would be the icosahedron, and then dodecahedron, right? So that would give us all 5 of the Platonic solids. What it would actually create is a perfect F sharp major chord. And this video does a great job explaining this to everybody. So I highly recommend that you look at this, because those that believe that there's no correlation between music and geometry, it's just not correct. Absolutely not correct. We just don't understand all the correlations between it, and we're now starting to understand it better and maybe remember it as well. So one of the other things I found was that these cycles, right, are fascinating, because we can look at how the periods of time are working, and they're all forming out of this cubes. Now, why cubes? What's the story with the cube? Well, the cube, I just said, had 2,160 degrees as the sum of its inner angles. And what's formed when we basically find all those angles of incidence on this chart is exactly these hypercubes all coming in and out of each other. So that becomes what's called a tesseract. And it can actually form in this direction or in this direction. And the nice thing about hypercubes is we can go multi-directional with it. And you can see many, many forms of a hypercube embedded within this. Now, the other thing is that, I don't know if you can see this on the side here. I think you can, okay. We have here fractals of time. So let's say we start off with 24-hour period, which is an hour, or from the original word Horus, the eye of Horus. So 24, and that's a 0 point of now, right? If we go up to look at the number of minutes that are represented in that 24-hour period, it's 1440, which equals 1/60th of a day. So think of that as one fractal. Now, if we go up to the next fractal, the number of seconds in that day are 86,400, the number I just mentioned over there, which is 3,600th of the day. And then if I break that again using 60s math, which is exactly what the Sumerians used, then I end up at 5184, or 5.184 million, I call them sexy seconds, because there would be, instead of breaking it into tens and decimals like we normally do, you would continue with 60s, because we have 60 seconds in a minute, 60 minutes in an hour, and then you would have 60 sexy seconds for each of those seconds. And then if I go a step further, I end up at again times 60. Now I'm going up to so the 5.184 million is 1/216,000th of a day. And then I go to the next level, which is 311 million, which also happens to be the longitudinal measurement of the Great Pyramid. And then finally, if I go do another level of 60s, this gives me then 1/216,000th of a second. And that comes out to 432 squared again, 1.86624. So so another way to look at this is if I took light speed, let me erase some of this stuff here. The closest number that squares to light speed is 432, which is a tuning standard of the note A. So 432 squared equals C in miles. Now, if I take this 432, and just remember that this number comes out to 186,624 miles per second. So closest squaring to light speed, which in a vacuum is 186,282. And actually, that's the actual measurement, most recent. But there have been several measurements that show this number actually oscillates. There have been measurements at 186,400. There have been measurements at 186,350 and 186,525. And all of this relates to this math constant Euler and divided by pi, because that's giving me 0.865. If I use Archimedean pi, it comes out to 0.864, right? So this is that same 86,400 seconds in a day. We add 1 to the front of it, we're back to light speed. Now, we have 86,400 seconds in one day. We're going to multiply this by 60 to see what happens, right? So 60 times 86,400 equals, right? So, sorry, there we go. 518,400, right? No, sorry, 5.184 million. That's what it is. Yeah, 5.184 million, but it's the same 5184. Then we take it by 60 again, and it's going to give me the 311,040. And I take it by 60 again, and it gives me back to this number, 1.86624, which is equal to 1/216,000th of a second. Now, geez, that's really amazing. Now, first of all, this 216 is this. Because the sum of interior angles of this is 2160. So time itself is related to these cubes. And as you go into the past or you go into the future as fractals, you're creating this zone of I guess you could call it consciousness or something. So you got 1440 hours is 60 days. 86,400 hours equals 3,600 days. 5184 hours equals 60 years. 311 million hours equals 3,600 years. And then at 1.86624 times 10 to the 10th power equals 216,000 years. The same 216. Therefore, the cubes of time a cube, sum of angles 2160. So another thing that we found out of this was that you could basically take pi and divide it by w. W is the lowercase form of omega. So pi divided by omega, which is a known value of 0.5, roughly 0.57, plus Euler minus 1 equals 1.718, is going to give us the age of the universe, 13.81 billion years. A simple equation giving us the age of the universe. And that relates to what's called the golden angle, 1.375 or 137.5, and it's known as the most mystical number in all of physics and mathematics, the 33rd prime number. So that's how cubes relate to time. And what really the flower of life is doing, it's the feminine form, the circular form, but for every sphere or circle, there must always be a square. And for every square, there must always be a circle. Just like for every sun, there must be a moon, right, in our consciousness. Now, one of the things that I find fascinating as well is that the sun and Earth have a distance of 93 million miles away from each other. If we double that, it comes out to 186 million miles. There's the same 186 that relates to light speed in miles. And then additionally, you can now look at the distance between all of the planets are just geometries within fractals. And this is one of the things that Kepler found, but the scientific community didn't really pay much attention to it. This is one of the things that Kepler found in all of his works on nested geometries. And so you could say that our work on nested geometries is making like virtually similar kind of smaller solar systems in a way of consciousness. Now, if you look at the distance from the Earth to the sun, which is 93 million miles, and you divide that by 400 times, you'll have exactly the distance from Earth to the moon. So that means that the moon is exactly 400 times closer to Earth than the sun is. And the moon's distance is, it has an average of about 230,000 miles away from the Earth. And of course, the Earth from the sun is the 93 million miles. It's 93 million and some change. It's like 93 million 250. Again, coming right close to that 186 400, 186 500 if you double it to find the diameter. Well, what's interesting about this is that the reason why we have a perfect eclipse, and we're the only planet in our solar system that has perfect eclipses like this, is because the moon miraculously is exactly 400 times closer to Earth than the sun is, and it has a diameter that's exactly 400 times smaller than the diameter of the sun. And what's the diameter of the moon, you might ask? Would you be surprised to know the diameter of the moon is 2,160 miles? Now, you could say that our entire measurement systems are arbitrary. The mile is an arbitrary unit of measure, isn't it? No, it is not. It actually relates to pi over 3, and you basically break that down so that it comes down to 1 minus 0.472 gives us 0.528, which is 5,280 feet in 1 mile, and it's a geometric relationship as well. And miles, and I mentioned also that the nautical mile even, the nautical mile measurement for speed of light equals 161,800 miles, nautical miles, which comes out to be the golden number. Now, nautical miles have been around a lot longer than our known measurements for light speed, but that's kind of amazing. So because of this very high correlation to 2160 on so many different levels, and by the way, the nautical mile circumference of the Earth, the equatorial circumference of the Earth, so this thing right here, the equatorial circumference, is 21,600 nautical miles. What a surprise. So, I don't know. You could look at all of this as coincidental. I don't. And I can say that, we're doing a lot of work to understand this. And one of the best things was being able to put together a research group that understood and could see all of these patterns as well in number theory and put them together, because I think that if we can really advance our understanding in physics and mathematics, then we'll be able to address a lot of the issues in the world today. That I think what's wrong with the world today is perception. We have a perception of scarcity. Everyone thinks that if I don't have enough toilet paper today, I'm going to run out of toilet paper. Now, by the way, I was a little concerned about running out of toilet paper for a moment. But the truth is that we have abundance all around us. And if we change our perception to perceive the abundance rather than the scarcity, we will find everything that we've ever wanted to look for, or it'll all be around us, just like we talked about yesterday when I told you the story about the Japanese monk at the Zen Buddhist temple who told me the difference between heaven and hell. And if we change our perception and understand that time itself might actually, in fact, just be an illusion, and I'm not saying this from the perspective of, purely number theory. I'm saying it from the standpoint of how scientists are actually looking at it today. You'll find a lot of data and a lot of information on the internet about time itself being a construct of our own observation. And that in of itself is interesting. And one of the other things that was found recently was that the sun, or rather the universe itself, is round. It's spherical. And with the universe being spherical, that means if you fire a photon into its outer edges, it should loop back and come back to where it started, like a giant boomerang. And if that's the case, then why is time only one direction? Or maybe what we're perceiving as time is actually our distant future, might actually be our distant past, and vice versa. There's a lot of things that we find that feel like remembrances more than anything else. And I think the ultimate scarcity we experience in life today is actually the scarcity of time. So if we can change perception of time and actually expand our own conscious awareness beyond the scope of the current time, then, and we'll maybe start seeing time as cycles of time, just as they're spoken of in the yugas, the Vedic mathematicians that have been around thousands of years and are completely beyond genius. And, we throw around the term genius a lot, but the fact is that all of us can be genius. The only thing, Walter Russell said, and I really believe in this quote, but Walter said that genius is self-bestowed and mediocrity is self-inflicted. I could not agree with that more. I don't feel like I'm, genius anymore because I'm not separate from anybody else. I'm the same as all of you. We're all part of the same thing. And the thing is that all of us are genius. Every single one of us on the planet are genius. We just have to choose to see it that way. Stop seeing in terms of scarcity and start seeing in terms of abundance. And it starts with time itself, because time brought gravity with it. And you talk about Adam and Eve in the garden. The first thing that God says to Adam is, Adam, what have you done? And Adam says, because he felt ashamed and he was naked. He said, the woman that you gave me, blame it on the woman. The woman that you gave me and commanded that I remain with, she gave me of the fruit of the tree of knowledge of good and evil, and I ate it. Eve, what have you done? The serpent beguiled me, and I ate it. So the first thing that came along with their shame was blame. And God had already warned him, the moment that you eat of the tree of good and knowledge of good and evil, that will be the moment that thou shalt surely die. And I don't think he meant he was going to die on the spot, because Adam lived a long time after that, hundreds of years. I think it was 900 plus years, according to the Bible anyway. The antediluvians maybe lived longer. We don't know. But the point is that what God was saying is that would be the beginning of time. And with time would come gravity. And with gravity comes going to the grave, the gravity. You're going to the grave, you're going to die. Time and gravity are the same thing. They are the vacuum of space. And space and time cannot be separated. They are absolutely inextricably linked with each other. And once we understand that all of this is connected through one nexus, and that one nexus is geometry, then it really gives a whole new meaning than just doing artwork related to geometry, because I believe our brains are more receivers than anything else. And as such, they have the ability to communicate with geometry that is universal. In a sense, let's say that we have a QR code reader inside our head, and our subconscious is able to read things and open up new levels of awareness and understanding just by looking at certain geometry. Or whenever new geometry is discovered or a new perspective on geometry is understood, then everybody is lifted. It's the one rabbit syndrome. You know, when researchers put rabbits in mazes, they want to see how long it takes for the rabbit to solve the maze. Well, it's kind of like the 4-minute mile. As soon as one person broke the 4-minute mile, it became easy for even high schoolers now. There are high school kids that break the 4-minute mile, whereas it was considered an impossibility in the 19th century to break a 4-minute mile, just as it was considered for rabbits to be able to solve very complex mazes. But actually, they found that rabbits can increase their understanding of mazes. Just because one rabbit learns it, then all other rabbits are now better for it. I think that's true also for humanity. And I think if we can all change the way we look at scarcity and start perceiving instead abundance, it can really change the world. Have a great day, everyone. Love you all. Bye.